Hey, hi everyone. Can you guys see us? Please comment yes if you can see us. And let's wait for a couple of minutes. Okay, someone commented yes. Okay, so let's just wait for 2 minutes so that other can also join. And today it's going to be definitely a good session because today we are going to talk about more advanced command that we generally use. Yesterday we only talked about few basic commands, and I hope you guys have practiced those. So I think we can start it. So yeah, I think over to you, Prashant. So Prashant will continue this series, and Prashant will teach you.
Yeah, thanks a lot, Shikhar. So, hey everyone, I hope all of you are doing good. So, this is the second part of our Git session, as Shikhar told you. So, those of you who have not watched the first session, I would highly recommend you guys to go over there and watch that session after this one. We'll have the link for that session in the link in the description of this video. So, yeah, let's get started. So, Shikhar, can you add my
Yeah, I've shared your screen.
Okay, cool. So yesterday we completed till branching, and today we'll now add on the top of that, and we'll see what all advanced commands are there for Git and how Git is actually used in our practical purposes. So that's all that we'll see today. So first thing that we'll see is yesterday, whatever we were doing, right, we were doing all of that locally, but that is not very useful, right? Generally, you'll be working with a lot of other folks, and you'll try to share your code with them. So today's session is something that we'll start with that. We'll cover how to host your code on a central server and basically how to share your code with someone, right? So for this example, we'll take example of GitHub, but there are multiple other services like that. For example, you have GitLab as well, which allows you to do the same thing. So what we're trying to do is we're trying to write a code and then we are trying to share that code with someone else. So how do we do that? So in the terminology of Git, this is something which is called as remote. So remote is a place where you push your code and basically from where you get someone else's code. So that thing is called as remote. So there are two ways in which you can have your code linked to some remote in, for example, GitHub. The first one is like the easiest thing that everyone does, right? You take someone else's code. So you copy someone's code. In Git terminology, it is called as cloning a Git repository. The other thing is you write your own code, which is a bit hard, right? And then what you do is you take that code and you create your own repository on GitHub or GitLab and then push your code over there. So we'll see how that is done. First example that we'll take is we'll take someone else's code and try to clone it up. Okay. So just a second. Yeah. So yeah. So now what we'll do is I have created this dummy repository. It currently has nothing. It only has like few basic stuff on top of it. And what I'll try to do is I'll try to take this code into my local system. So how do I do that? This would actually differ from which UI you're going to. But for GitHub, the steps are as follows. In GitHub, you see a code section over here, which tells you what.
Sorry. Can we zoom a little?
Yep. Sorry. This should be readable, right?
Yeah.
Okay, great. So there is this code section on GitHub, in which you'll see mainly two options. There is this third one, but that we can ignore for now. So first one is called HTTPS, and the second one is called SSH. So GitHub is telling us that, hey, you can clone this code into your local system using two protocols. You can either use HTTPS, or you can either clone the code using SSH. Generally, SSH is something that you would be using because it is easier to do that. Because the problem with HTTPS is you need to enter your GitHub username and password to clone that. But for SSH, you have something called as SSH key, which helps you get this code into your local. So how to set up SSH key is something that we won't be covering now. That is something we'll put a link in the description of the video, and you can use that. It's a pretty straightforward step. You just need to go to GitHub settings and upload your SSH keys over there. So for now, what I'll do is I'll copy this command or copy this particular URL, and then I'll go to my terminal. And then what I'll do is I'll clone this repository, which is currently present on GitHub, into my local system. Okay. So how to do that? The command to do that is git clone and the URL that we had. Okay. So the URL is git @ which indicates it is a SSH key based link, and then finally you have your repository link. So once this happens, let's see what it does. Yeah, so it did something, right? It first said that, hey, I'm cloning into a repository called as dummy repo. Then it also said that it is getting some data from GitHub. It is compressing all of that. And then once it has it, it has all of that data local. So what now happened was it created a directory called dummy repository in my local system. And now let's take a look at what all do we have here. So if you take a look over here, we have a readme.md file, we have a license, and we have some file called .gitignore. So if you go over here, that's what you see. So this command called git clone, what it does, it takes a remote repository and it clones that repository into your local. So in your local now you have the complete history of this repository. I think this repository is pretty simple, so it won't have a lot of data. Yeah, it only has like 2 commits. The first commit said initial commit, and the second commit is where we updated a .gitignore file. This file is something that we'll talk in next few minutes. But for now, I would also like you to see some other information over here. It is telling me a few things. It is telling me that, hey, your head is pointing to a branch called main, and it is also pointing to a branch called origin main and origin head. So what are these 2 branches? So what happened was this particular Git repository on GitHub, it also had these branches. It also had a branch called main and feature 1. Okay, so this particular branch main in a remote is called as a remote branch. The similar branch you also have in your local. So when you clone a code from GitHub, you also see some branches which would look very similar to yours, but they would have this prefix called origin before them. Okay, so let's try to understand what does this origin means. When we did a git log, we started seeing this origin. What does this mean? It is a name given by Git to your remote system. Okay, so whenever you have a remote system where your code is being synced, that remote system needs to have a name. Git needs to find a name to identify that system. By default, the name of that system is called as origin. So let's check that. There is this command called as git remote -v, which tells us something. For example, the command is git remote -verbose. That is telling me that I have a remote named origin whose URL is this, and it is used to get data from remote. I have a remote called origin, again the same remote with the same URL, but it is allowing me to push to that remote. So what does push means? Push basically means whenever you make a change into a local, you would also want to share that change with someone else, right? So that is where you can make use of push. So let's do that, right? So what I'll do is I'll open readme.md and I would write something like change made by local system. So if I do a git status now, Git will tell me that I modified a file called readme.md. And what I need to do is I need to add this file in order to commit it. So yeah, let's do that. Git add readme.md and then git commit -m updated readme from local. So yeah, this looks like we have a new commit now. Yeah, that is this commit, updated readme from local, done by me at this point of time and with some commit ID. So now what we'll do is, let me run a git status. So git status is now telling me something. It is telling me that, hey, you're on a branch called main, and this branch is ahead of origin's main branch by one commit. So, and it is also telling me what you can do. You can run this command called git push to publish your local commits. So yeah, I can do that. I can just run git push. And what would happen is the changes that I have in my local would be reflected on GitHub. So as of now, if I go to GitHub and open readme.md, I only see a line called dummy repo. I don't see anything else over here. But if I do git push, what would happen is Git would take my local changes and push these changes to remote. So yeah, what it just did is it pushed changes from my local main to the main of remote. So let's go to GitHub and see what is happening. So this is a readme.md file. Yeah, if I reload this, I now see the changes that I made in my local system. So yeah, that's done. Now let's try to do this in the opposite way, right? What if there was one more developer who's working with me and they made some change? One other example where we can take this is, right, for those who attended yesterday's session, we were taking an example of the assignment given by professor. So if we take that example, so what happened was professor gave us some operations to do, addition, multiplication, right? So what if you and your friend decide to do some sort of parallel task that, hey, I'll do addition and you go ahead and do subtraction. So in that case, what could happen is both of you are working on the same code base. And while you're making changes for addition, the other guy is making changes for subtraction. And he'll push those changes to GitHub. And now you need to get those changes into your broken. So how will we do that? So let's do one thing, right? Since I don't have another developer over here directly that I can ask them to make the changes, I'll go ahead and change this file directly from the GitHub UI. So, and I'll write something like change made by someone else. Okay. And GitHub will allow me to directly commit these changes from here. Yeah. So I see these here. Now let's see if I got those in my local or not. So let me see what do I have in my README. My README currently only says changes made by local system. It is not telling me that the changes that were made by GitHub. So how can I get those changes? Let me do a git status. See, git status is currently telling me that your branch is to date with the main branch present on my origin. But I know that is not true, right? I just saw some other changes present over there. So how can I get those changes? For that, there is this one command, which is generally very useful. This command is called Git Fetch. Okay, so what Git Fetch does is it gets all the data for the branches present on your remote to your local. Okay, so let's do this. Okay, so Git Fetch did get me some data. Now let's see what happens when I do Git status again. So now Git status is telling something else, right? It is telling me that, hey, if your branch is behind origin main by one commit, it means there is a commit on remote on the GitHub, which is not present in my local system. And it is also telling me how I can get that change. It's telling me that why don't you do a Git Pull and you'll get that change in your system. So yeah, let's do that. So if we do a Git Pull, it said that, hey, it changed one file that was readme.md and one more line was added over there. So now what we'll do is we'll see what is present in readme.md. So now we have the change which was made by some other developer, right? So yeah, that is the most important use case of why we need Git and why we actually need a remote server where we can share code with other folks. So if I go back to my presentation, this was the first part of it, that we can copy someone else's code. But what if you actually have to write your own code and push that code to remote?
Prashant, can you just explain the difference between Git Fetch and Pull again? Someone asked.
Oh, yeah, definitely. So what Git Pull does is, Git Pull takes the content present in the remote branch. For example, if I'm currently on a branch called main, Git Pull will take the change present on remote's branch called main and get all those changes into my local system. What Git Fetch does is, Git Fetch gets the change present in origin main and syncs those changes in the origin main in my local. See, remember, main and origin/main are two different branches. Okay, main refers to my local main branch, while origin/main refers to a reference to the branch present in my remote. So when I do a git fetch, my local Git will know that, hey, there is some change which is present on origin/main, which is not present in my local main branch. But it doesn't get those changes into my local main. To get those, I still have to do a git pull. Or, okay, I will explain this later on. We have not covered that topic yet. There is one more way to do that. But this is the basic difference between fetch and pull. Fetch gets all the metadata about all the remote branches present into your origin. Pull actually gets the data present in your current branch from origin and pulls all of that data into your current branch. So yeah, that's there. So yeah, I think we'll move on to the next topic now, which was how we can create our own remote repository. So sometime back, Shikhar took a session around how to create a notification system for Covin website, which was calling Covin's public APIs and triggering a notification. So what we'll do is we'll go to that code. So yeah, this was that repository that she had created. So if I show you source main job. So it had like few files called vaccination service, session, root, main, and center. So now what we'll try to do is we'll try to push all of this code into Git. So how do we do that? First thing is I'll copy the name of this folder, which is Covin notification. Then I'll go to GitHub. In GitHub, you see this new option. You do that. You copy the repository name over here, and then simply click on create repository. So what GitHub will do now is it will create a remote repository called Covin-notification, but with no content on it. It is currently an empty repository. So if you actually scroll down to the second section over here, there are some commands present, and the title says push an existing repository from the command line. So what this section is about, you already have some code base into your local, and you want to push that code into the remote system. So let's look at one command at a point of time, right? First command that it is asking us to run is Git Remote Add Origin and the URL of this particular repository. So what does this do? It tells Git that, hey, can you please add a remote called origin, which has this particular URL. So yeah, as I said, you can actually use any particular name over here, but origin is the default name that Git uses and is actually used at a lot of conventions. So we'll stick with that. We'll run this particular command. So yeah, the thing is, we'll also need to do a git init. Yeah, so now our repository is up. So yeah, we just added a Git remote to our Git repository. Now git status, git add dot. Okay, by the way, this is something that we didn't talk about last time. Git or add dot basically adds everything that is present in a system. It is generally not a good idea to do this, but since we have a lot of files, we'll go ahead and do this. So git status should tell me that I have a lot of files that I need to push. So git commit -m initial commit, and then I'll take this particular line which is basically doing nothing but having a branch called main. And then I'll run this command. So now what is this command doing? You remember the last time when we ran git push, we only did a git push. We didn't pass anything else, right? But here we are doing something else as well. So let's see why we have to do that. What I'll do is I'll just do a git push and see what happens. Git push just threw me an error. It said that the current branch that you have in local, it doesn't have any branch on remote. So that's why what Git, it is also telling me how to fix this. It is telling me to fix this, your origin should have a branch called main that I know exists. And then you should also use a flag called -- setup stream. The shortcut to that -- setup stream is also called as -u. What this does is it tells Git to start tracking your local main branch with the branch present in origin main. So let's do that. I'll just use the short form of -- setup stream, which is -u, and do this. So yeah, it pushed everything, and also it did one thing more for me, which is what -u did. It is telling me that, hey, your branch main is now tracking the remote branch main from your remote called origin. So now I can very easily do git push and git pull without always having to type this long command. So yeah, that's I think that's all about remote in Git. There is one more thing that we'll cover, which is called as .gitignore file. So generally what happens is when you're sharing code with a lot of developers, right, there are like certain things which you would want to be present in your local. So what are those things? There could be some credential files present in your local system. When you run your code, there would be some build files. For example, in case of a C++ file, it would be a .out file created. Or if it is a Java code, you will have a jar created, or you will have a lot of classes generated. You don't want to share all of this with all the developers, right? You only want to share your code that they need. You don't want to share your credentials with them. So for that, what happens is Git has a functionality called as .gitignore. So yeah, let's see that thing in action. So what I'll do is I'll create a file called password.txt, and I'll say git password equals to my git password. So it is my git password. Now what happens is, if I do git status, Git is telling me that you have this file, and if you do git add, it would Git would start tracking this. But I don't want Git to start tracking this. I want to make sure that Git never reads this file. So what I'll do is I'll create a file called .gitignore, and in that I'll add password.txt. Now let's look at what happens when I do git status. You see, I still have the password.txt file present in my system. But Git is no longer looking at that file. Git is now only asking me to add my gitignore file, which I should actually do. But Git is not asking me that, hey, any password.txt file exists. So this is like generally a very important topic. You need to be aware that you don't end up committing your passwords. You don't end up committing the build files. You only share the code that everyone else needs with them, nothing more. So yeah, that's it. Now we are done with remote. Shikhar, do we have any questions that we can take from anyone?
No, I've answered almost all of them. One question I didn't understand, so I think we can cover it later if we. So you can proceed now.
Okay, sure. We'll cover all the remaining questions at the end. So yeah, now since now this is done, we know how to share via our code with everyone else and how to copy someone else's code. We'll move forward to the next topic. Oh yeah, this I already covered. Yeah. the advanced commands that we have. So yesterday we ended our session while talking about branching. Today, most of the stuff that we'll talk about revolves around branching and revolves around how to fix our mistakes. So the first of those commands is called as Git Merge. So to explain to you how Git Merge would work, I would take you back to the visualization tool that we were using last time. And we'll also go back to the example that we were having yesterday. So what we were doing was we got a assignment from professor to implement
Can you zoom
few
in?
operations. Okay, sure. So just a second. Yep. So yesterday we were talking about an example where we got assignment from professor saying that we wanted to implement addition, multiplication, division, and subtraction over a period of few days, right? So we'll take the same example and see what is happening with branches and why do we need something called as Git Merge. So the assignment that we got was we wanted to implement some operations over here, right? So what we did was we first created a branch called project. And then we did a checkout to that branch. And then we started implementing whatever was given to us. So first day we implemented addition. Next day we implemented subtraction. And now professor came back to us saying that, hey, can you give me division today itself? So what we did was we went back to our master branch using this command git checkout master, created another branch using command called git branch, and gave it some name like division, and then went to this branch. And then what we did was git commit -m division. So we implemented division over here. And then let us say there was some mistake in our division and we wanted to fix it. Maybe we were not dividing it correctly and it was getting typecasted to end. So we fixed that, fix division. And now we went ahead, showed this code to professor, they're happy. So what we started doing was we came back to our project branch. We implemented multiplication. Now what happened is now it is like the end of the project and we want to show all of our code to our professor. Now the problem is we have implemented all of this. We have addition, subtraction, and multiplication in our code, but we don't have division as of now because that is present in a separate branch. So how do we solve that? The first thing is we take all of that code, we again start implementing all of that. But that is not the most efficient way. What we can do over here is we can get all of that code back into a project branch. So for that, the command is called git merge. What git merge does is git merge, the syntax for git merge is git merge branch name. So git merge takes all the commits into that branch after it bifurcated from the main branch and puts and takes these commit and get all of this data for you. So for that, what git merge will do is it will create a new commit consisting of all these changes and add that commit in your current branch. So let's do that. Git merge. Our branch name was called division. Now see what happens when we do that. When we did that, a new commit was created, which had all of these changes, and our project branch started pointing to this. So now we have a commit which has all the addition, subtraction, multiplication changes, as well as it now also has a division change. So yeah, that's how merge works. So now what we'll do is we'll actually try to go to terminal and see how we can get to see merge in real life, right? So what I'll do is I have some data already created. So this is the repository that I created merge tutorial. I'll show you what it has. It just has nothing but 2 commits in which I was just adding some data to a file called main. And if I show you how that file looks, this has nothing but the first time I added a line called this as main data, and second time I added one more line calling this as more main data. Now, let us say what started happening was you had to develop some feature. Okay. So what you did was you created a branch called feature, and then you'll go to that branch. So now there is one thing, right? I have always been writing these 2 commands to go to a branch and create a branch, which is git branch name, and then I do a git checkout branch name. There is a smaller way to do that, which is generally like more preferable. What we do is git checkout -b branch name. What it does is it will create a branch with this name and also go to that branch in one single command. So yeah, let's do that. So we have now switched to a new branch called as feature. So now what I'll do is I'll create a file called feature.txt and write some content over here, implementing a new feature. So .txt and then git commit -m working on a feature. So yeah, now we have a commit over here. Now let's go ahead and complete this feature. So for that, let me again open the file and write feature completed. And again, the same thing, finished feature. So while we were working on this feature, there was one more bug that came into our main branch, and we have to go ahead and fix that. So I'll go to my main branch, git checkout main, and I'll open my file in main.txt. And then what I'll do is fix the bug. So if as of now, okay, let me also add this and then git commit added a fix. So as of now, if I look at my log, my main doesn't have any data about fix because your main branch is separate. And if I go to my other branch called feature and take a look at Git log, here you see whatever we did for feature, but we are not seeing any fix that we made. Right. This is also apparent from if I do what is present in my feature.txt, I have feature, and I don't have my bug fix in my main. While if I go back to my main branch and see what do I have in my feature.txt, the file doesn't even exist as of now. And my main.txt has fix as well. So now this is done. Now I want to get the feature that I implemented into my main system so it can be deployed. So how to do that? The merge command comes into picture here. So to do that, I'm in my main branch. I do a git merge. And then what I'll do is I'll pass the branch that I want to merge. On doing that, it opens the same commit message terminal. And then here it is telling me the default message that it has, which is merge feature. So this message looks good to me. I'll go ahead, save it, and Git just made a merge for me. So now if I take a look at Git log, I'm seeing a lot of things here. This is the merge commit that was made. We also saw the same thing here, that merge actually creates a new commit with all the changes like this. And then we have added a fix. We also have a feature over here. We have everything. But this actually looks a bit difficult to look at. So for that, we can actually ask Git Log to add some more data over here. --graph. So if we add these things, the Git log looks a bit more cleaner, and it is easier to understand what is happening. So these were the two commits that I had earlier. This particular line that you're seeing here is the main line. So what happened in main line was we added a fix. While a separate branch started, where we started working on a feature, and we also finished that feature. And later on in our commit with ID this, we started getting all the changes. So yeah, now we already see that we have both the changes. We had feature.txt as well as main.txt. So our merge is successful. So this is like a very simple example of merge where we didn't see any issues. But we are not always that lucky. Sometimes what would happen is when you're trying to do a merge, more often than not, you'll run into troubles. So let's take an example of how that happens. We'll go back to our previous example where we were implementing all of those operations. So let's do that. So this is like exactly the same stage where we were last time. I'll show you what all we have. So in our project branch, we implemented addition, subtraction, and multiplication. But we also had a branch called division. And if I look at that, that only has implemented division. And if I look at my file called a.cpp at this point of time, it only has divide. While if I go to my project branch and do cat, I see addition, subtraction, and multiplication. So now it is the time for me to get the division changes into my project. And let's see what happens when I try to do that. So I do git merge. Remember, I'm currently in the branch called project, and I'm trying to merge division into this. So I do a git merge division, and let's see what happens. Now this time Git is telling me something else. It is telling me that, hey, you have a conflict in a.cpp. So what does conflict means? Conflict is basically telling you that while you were making changes in your branch, someone else also made some more changes into the branch that you're trying to merge. And since those changes are in a single file, Git cannot figure out which changes to keep and which changes to discard. So Git basically now relies on you, and it will ask you to manually fix those changes. So let me open this file and see what is happening over here. So see what happened. Git is telling me that, hey, the branch where you are currently at, which means where your head is, you have these three functions: addition, subtraction, and multiplication. But from the branch that you're trying to merge, which is division, has these changes. How do you want to merge them? So in our case, like since it is a simpler conflict, we can very easily figure out and fix the issues. But first thing that we need to do is we need to delete this line. We'll delete that. We also need to delete this line. We'll delete that. And then we are missing a empty curly braces over here. So we'll add that and then delete this line. So this way, I can resolve the conflicts and now have all the changes into my system. But generally, like this is not very intuitive. It is very difficult to figure out how to fix these issues. So that's where there are a lot of UI tools that you can use. Even the IDs that you use will have some sort of Git conflict resolution UI present over there. For example, IntelliJ IDEA, which is a Java-based IDE, actually has a lot of functionality around how to better fix these conflicts. So I don't have IntelliJ IDEA into my system. So I'll just show you a screenshot of something that I found online. So this is how this looks like, where you see that, hey, these are the changes added by feature2 branch, and these are changes present in master, and how you can fix them. You can get something from here, or you can get something from here. There was also a link that I missed.
Sorry to interrupt. Sorry. Just before adding this, I just wanted to add one point. Like to open this thing, you just need to right click on your screen, and there will be option of Git. in IntelliJ, and then you can see resolve conflicts, and then you will go to this screen where you can resolve the conflicts. So it's very much easier rather than resolving your conflicts directly in the file. Here you can just see that on the left screen one version, right screen one another version, and then in middle screen you are seeing what you finally want to achieve. So you can just like select which all things, like maybe let's say one line you want from left file and another line you want from right file. So you can see in the screen that it's giving an option of accept and cross. So you can just click on over there and you can resolve. And again, yeah, you need to like try practicing it today, because this is the most important part, like much conflict that people are generally scared of, but it's quite easy. And yes, so just after the session, this session will be available on YouTube only, and just for VS Code, I didn't find any. We were trying, but we didn't find to such terminal where it is providing. So IntelliJ is much better for that. But you can again Google it if VS Code provides a functionality. But the main thing is, yeah, you are able to resolve the conflict. So after the session, make a file, then make a branch, made some changes in one file, then make another branch and do some another changes in the same file, and then try to merge them. So you will get conflicts. So guys, yeah, again, so you need to practice after the session ends. Only then you will be able to understand, because it is not easy, because we are covering all the commands in one session. Yeah, so you need to practice one by one. Yeah, Prashant, carry on. Sorry.
Yeah, thanks a lot for that. So what we'll also do is we found a guide online where it said that how you can open all of this into IntelliJ. We'll add the link for that into the video description as well, so that it is easier for you to find that. So yeah, now since this is resolved for us, I'll go ahead, save this file, and see what is happening in Git status. So yeah, Git status is telling me some things that, hey, you need to fix conflicts, and then you need to run Git commit. So yep, let me do git add a.cpp and see what is Git status telling me. It is now telling me that you have fixed all the conflicts, but you still need merging. And to do that, just run the command called git commit. So let's do that, git commit. It will show me the merge command, it will show me the commit message which will come in, which is merging branch division into project. That's good to me. So we'll do that. So if this is done, I'll again run the git log command. And yeah, we again have the same thing. In our main branch, we implemented addition, subtraction, and multiplication, which was our project branch. And then there was a separate branch division in which we implemented division. And finally, we started getting all of the changes over here. So yeah, that's all about merge. Now, what we'll now learn is the second command, which is git rebase. Git rebase is like very similar to merge, but just a different version of it. But still, it achieves the same thing. So let's go back to this UI and see what we'll do. We'll try to reach the same stage. We have some commits present in a master branch. Okay. Now what someone does is they create a new branch. And now I'm using the shortcut to create a branch and also check out to it. Git checkout -b branch 2. Yeah, let's use better names. Feature. And then they added few commits on the feature branch. While they were adding the commits on the feature branch, what also happened was in the master branch, some of the fixes were added. So let's add those commits. Okay.
Can you zoom a little? Like maybe someone is asking.
Oh, okay. Now after this, I think it runs out of the screen.
Okay, then just zoom out. We can do zoom out. Yeah, do zoom out. It's fine.
Yeah. Okay. So now what I want is I want these feature changes into my master branch. So we already saw one way of doing this, which is we can run git merge feature and it will create a new commit over here. which is what we were seeing here. It created a new commit over here, which had all the changes. But the problem of that is your history looks a bit dirty because you have one extra commit and you still have that commit pointing to two different parents. So it is difficult to like travel across your Git history. So to keep that clean, the command is called as Git Rebase. So what Git Rebase does is, as of now, if I try to do a Git Rebase feature, it will take these three commits over here and put those in front of feature branch. So let's look at how this looks, right? Git Rebase feature. I'm currently in my master branch and I'm rebasing my feature branch into my master branch. So now you're going to see some sort of really nice animations. So just look at that and see if that makes sense to you. First thing that would happen is your head would move to feature. Then these three commits would be created over here. And then your master will move to the top of that commit. So let's see how that looks. So your head moved here. These three commits are created over here. Then your master moved to the top. So now because of this, the clean thing is you have a straight line over here. You don't have like multiple parents for a particular commit. So that's why Rebase is generally used when you want to keep your history clean. So if as of now someone looks at this master branch, they have all these three commits, which will earlier present over here, as well as the two commits which were added in the feature branch. Now, some of you might be thinking that, hey, this commit is not same as this commit. This commit's ID is 2FB5B6C, while it has a different ID. Why is it like this? So these commits still have the same content. They do not have anything different. If a single line was added in this commit also will have that single line itself. But the problem with Git is, or actually the benefit of it, is when you are actually doing a Git commit, Git doesn't just take the content of the file. It also takes a whole lot of other information. Who created that commit? When was the commit created? And then the commit ID or the hash value generated is a combination of all of this. And because these values will always keep on changing, your commit ID will always change. So yeah. So having said that, Git Rebase is something that I don't think folks would be using a lot. But this is useful if you're just making changes in your local and you don't want to see all this messy multiple lines coming in your Git log. So that's when you can use this. So yeah, I don't see any issues on Git Rebase. So I'll move to the new topic, which is Git Revert. Yeah, this is something that I think all of us use at some point of time. And when you have to use that, it means you actually made some mistake and you have to correct that now. So let's look at what is Git Revert. So sometimes what happens is you implemented a feature, you tested that feature, and then once you merge your changes into the main branch, after that you realize that you've made some mistake, right? And the problem with Git is if you made a commit, now it is very difficult to get rid of that commit. There are ways to do that, but those are not recommended. So now how do you undo something that you already did? So that's where Git Revert comes into picture. So let's take an example. Okay, so let us say we did this. We added a feature over here. But now, as soon as I did this, I realized, hey, there is a major bug in this. I need to get rid of this. So how can I get rid of that? So to do that, the command is called as git revert. So the syntax for git revert is git revert and the commit that you want to revert. For example, in this case, the commit that I want to revert is this one. So either I can just copy this commit, paste it over here, and revert this. Or the other way to do that is whenever I'm just trying to revert the place where I'm present now, that thing is always called as head. So head is a pointer to my current snapshot of working directory. So if I just want to revert my current commit, I can always simply write git revert head. So now once I do that, what would happen is Git cannot delete a commit, first of all. We were talking this about in our last session, that Git never deletes a commit. Or Git, all the operations that you do in Git are always additive in nature. So what will happen is, as soon as I do this, what Git did was, it took this commit and looked at all the changes that happened in this commit, and then created an exact negative of that commit, and then created that commit. So now, if you look at your repository at this point of time, it would look like as if this never happened. Okay, so that is like Git revert from here, but we'll also like to see how Git revert takes place when we actually try to do this from terminal. So what I'll do is, I have few files here, which is a.cpp, right? So I'll open my file a.cpp, and what I'll do here is I'll change my multiply to use long X and long Y. Okay. So I'll save this. I'll again do add a.cpp and git commit -m use long for multiplication. So yeah, that's done. So if I open my file now, I immediately recognize that there is some issue. The issue is that I have two long values and I'm multiplying them, but the return value is an integer. So I need to fix that. But it might take some more time for me to fix that. I want to revert those changes as fast as possible. So now what I'll do is I'll revert this change. What I'll do is a git revert head. So yeah, Git created a commit message for me. It was revert use long for multiplication. Let's save this. And let's look at Git log. So this was the commit that I had, in which I added use long for multiplication. And this was the revert commit added by Git, which was revert use long for multiplication and some more information that, hey, this guy is reverting a commit with this ID. So let's take a look at what happened in this commit. So git show. So here I changed int x int y with long x long y. And now let's take a look at what happened in the revert commit. Here, see, it again did the exact negative of what we did in git commit, in our previous commit, which is it replaced long x long y with int x int y. So yeah, that's how like git revert is like very useful. I mean, in this example, it looks very simple, right? Why did you have to do a git revert? You could have simply changed two long words with two int. But generally, when you have to do git revert, it is because you have changed like 5 or 10 files, and it is going to take you a lot of time to change all of that back. So git revert does all of that for you in a single instant. So yeah, git revert is like one of the most useful commands that you'll see. Okay, I think there was some question there, right, Shikhar?
Yeah, there are two questions. One is, but I think we can complete like remaining two commands, and then we can discuss the questions all together.
Okay, yeah, sure. So yeah, now we only have like two commands left. One of those commands is called as cherry pick. Sorry, yep, I'm here. So you remember yesterday when we were doing this example, I made a mistake. I made a commit without actually switching a branch. And then I was like, how do I fix that? So Git actually Git is so good that it allows you to fix each and every mistake that you make. So let's see what was the mistake that I made yesterday and how can we fix that. So what happened was, it was the same professor example. We created a branch called project, and then we implemented a few things. We implemented addition, we implemented subtraction. Then I went back to my main branch when I had to implement division, and I implemented division directly from here without creating a division branch first. So this is now a problem now. How do I take this commit and move it to a separate branch? I wanted to correct my branch from here. So how do I do that? In such scenarios, and actually there are multiple such scenarios, where what you want is you want the commits present in some other branch into your current branch. So that's where this particular command called cherry pick comes into the picture. So what cherry pick does is it takes a commit or a set of commits. It can take like multiple commits at one go and puts those commits into your current branch. Okay, so now let's try to fix this particular scenario. So what I'll do is I'll go back to this particular commit where I started. So there are two ways to do that. First is I do git checkout and I take the commit ID and go over here. So my head will move over there. But this, like, generally it is very difficult to know the commit IDs, right? So there is like a better way to do this, which is you do git checkout head -1. So what does this mean is head is where you are currently. -1 basically means go one step behind. You can do this -2, -3, and so on and so forth. So since I just want to go one step behind, I can do git checkout head -1. It will take me back one commit. So here I create my correct branch. And now when I'm on correct branch, I want to take this commit and pull this into my current branch. So for that, the command is git cherry pick and the commit ID. What this will do is it will create another commit with exactly the same content as this commit and put that in my current branch. So let's see that happening. So yeah, oh, I think I'll need to scroll a bit. Maybe we decrease the font. Yeah, anyways, what happened over here was it took this commit, it created another commit with the same content as this one, and then put that commit in my current branch. So I could have done this yesterday without having to go back, delete the project, and create all of that again. So that is something like Git helps you a lot. You don't have to think that now you mess something up. That would never happen. There are always ways to fix everything that you do in Git. So yeah, this is cherry pick. Now, the last command that we want to discuss today is called as Git Stash. And yeah, this is, I think, like another very important command that you'll be using a lot. So let's go back to our Git tutorial, okay? Now let us say we also want to implement another function over here, which is power. We want to find the power of two variables, okay? So I open my file, I start implementing power, okay, and power int x, int y, and I'm just writing the code to do that, right? But it is still not completed because this function is really complex. It will take me a lot of time to do this. So, but meanwhile, what happens is the professor comes back to me saying that, hey, you need to add this simpler function over here. But all of this change is not yet done. I'm still trying to complete the power function. So what is currently happening is I have an incomplete function, which you can see using git diff, but it is not yet completed. I still am trying to complete this function. But as of now, I got something else. I need to work on that. So how can I do that? One way is I delete all of the extra code that I just wrote, and I go back, complete what was given to me. And once all of that is done, I come back here and start writing all of this again. But that is not useful, right? What if you have some incomplete code, but that is like across 4 or 5 files? You don't want to delete all of that. That is where Git Stash helps you. What Git Stash does is it takes everything present in your working directory, either modified files or if it is present even in the staging area. So whatever is not committed and modified, it takes all of that and stores it in something called as stash. So as soon as you do a git stash, you have all of those changes now removed from a working directory, but not lost. Those are now saved in something called a stash. And once you're done with the changes that you're doing, you can again come back and get that stash back and start working on what you were working on. So yeah, let's take a look at that now. So let us say when I was working on this, I had to go back to my division branch. So I do that, git checkout division, and it is like giving me some error that, hey, you have some local changes in a file called a.cpp, but if you change your branch now, those changes would be gone. You have to do something. So it is asking me, it is only giving me two options. First is you commit to your changes, which I can't do because the PowerPoint is not yet completed, right? The second thing it is telling me is, why don't you stash those changes and use them whenever you want? So what I can do is, I'll do that. I'll do git stash. So now it is telling me that whichever changes you had are now saved into a stash. So if as of now I do git diff, I won't see anything. If I cat my file a.cpp, I no longer have those multiplication changes over here. So where are those changes gone? How do I see them? So I do git stash list. It basically tells me all the stashes that I have saved in my system. So it is telling me you have only one stash, which is some work in progress that you had on this commit, and you can use that stash anytime that you want. So I go back to my division branch. I do git checkout division. I do whatever the changes I want to do. And once those changes are done, I get back to my project branch. And then it is time for me to get my stash back. So how do I do that? For that, the command is called git stash pop or git stash apply. So as soon as I do git stash pop, it again got my stash back, which was a.cpp. And it is now telling me that, hey, now your changes are over here. And I've dropped this ref. It is no longer present when you do a git stash list. So git stash list is now empty. So yeah, now I can complete my multiplication changes and then use those. Sometimes it could happen that you have more than one stash. For example, let's stash these changes again so that my git history is clean. But what I'll do is I'll again open a.cpp and maybe add some other line over here. Hash include git slash std c++.h. But now still the code is not complete. So I can again stash it. And if I look at git stash list, I'll see I have two stash. Okay. One is stash @0 and one is stash @1. You can actually give like more meaningful names to these stashes that you can find in stash commands help, how to do that. And you can do git stash pop and the name of the stash, and it will like get that for you. So you can like have multiple stashes and only get some of them. So yeah, that's about stash and is generally used when you have some incomplete changes that you have not completed yet.
Yeah, so, if I'm not wrong, it's just one thing. If I'm not wrong, like stash is, can we say stash is an example of a stack, an application of a stack?
Yes, that is correct.
Yeah, so like
that's why we actually use exactly the same commands called as git stash push and git stash pop.
Right. So even in interviews, sometimes people ask like, what is the examples of, and people only ask what are the uses of data structure. So one of the use you just saw. So git stash is like your stack, and you already saw that Git is a perfect example of using graph theory. So yeah, anyway, I think, yeah. So I think we are done with the session. We have a couple of doubts that will clear. Just removing the screen and I'll just pop up those questions. So first question is, yeah, Shan, can you answer?
Yeah.
Are you able to find the windows? Okay, fine.
Yeah, I can see that.
Okay. Cool.
Okay, so the question is, do Git log cover log for all the branches present in repo, like maintaining a single log file? So no, this is not exactly true. When you do a Git log, what Git log will do is it will find your head wherever you're at currently, and from there it will keep on going one step backward up until the root commit. So if someone has actually started some other branch, you won't see that in Git log. if that branch is not merged to your branch, or that branch was created after you started your branch. But having said that, now there are a lot of UI tools. For example, there is something called as Git Kraken and even IntelliJ and all. What they do is when you look at their logs, they actually show you everything. So they actually show you all the branches present, even if that is not your branch. But once you do a Git log, it only shows you everything starting from your branch up until the root node.
And the next, second question was this. Okay, if you can just tell in brief again.
Oh yeah, this is a really nice question. What is the difference between Git Pull and Git Merge? So let's take the first one, which is Git Pull. So when, let us say I'm on my main branch and I'm doing a Git Pull, by default, what it will do is it will take the origin/main and it will get all of that data into my main branch. So now here, two things can happen. Let us say I don't code anything, right? And someone is actually coding on the main branch. And in the main branch, in the remote's main branch, there are like 2-3 commits over there. And as soon as I do a Git pull, it will get all of those 3 commits and put those into my main branch over here. So even in this case, what is happening is my main branch is getting a merge from origin's main branch, but it doesn't look like a merge to you because Git does certain optimization for you and it figures out that, hey, you have not made any changes. There are only certain changes present in origin's main branch. So it will just take all those 3 commits and put it in front of your local main branch. But sometimes that might not be true. What would happen is you have your local main branch, you'll add a commit on that. And in the remote, someone has already added 3 commits on remote's main branch. So at this point of time, if you try to do a Git pull, Git will tell you that, hey, your branch and remote's branch has now diverged, and it will now need to do a Git merge to take that main branch and put it into your local branch. So to answer your question in short, Git pull also does Git merge, but Git optimizes that to not always have to create a Git commit. So you'll see certain things like Git is doing a fast forward into your local branch. So things like that would happen. But having said that, Git pull is Git merge and optimized Git merge.
Okay. Yeah. Other questions you guys can ping us on LinkedIn. I think these are the basic questions that we can cover on LinkedIn also. So yeah, I think we are already over time. So and I think we have covered everything on Git. So I think we have another prepared your assignment. We have extended the assignment so that you can practice now this session commands also. So I will just paste the assignment. It's like basically the same assignment. We have extended over there only. So you can just practice those commands. And again, I'll again ask like, please practice, because without practice, development is nothing. So yeah. And one more thing is, I think I wanted to cover 2 things. Yeah. So one is this, and another thing is like, so guys, we are starting something new, and it's a basically like it will be a session of mock interviews. Not session. It will be a like it will be an online paid program, and I will post the details on LinkedIn also. But in brief, I'm just telling like so it will be a complete 4 or 5 set of interviews, which will be taken by obviously like experienced professionals who are working in Google or Amazon or maybe from outside India. So yeah, and focus will be on like people who are working in some companies, and they are looking for switch and they just need practice to do those mock interviews. So yeah, I'll post the details on LinkedIn, so you can just keep following me over there, and you'll get the updates by tomorrow, day after tomorrow. And just one last request is, guys, if you please like the session, just comment on the video, not here on the chat is fine. After the video ends, if possible, please comment on the video so that other people can also know like this session is good and they can also watch. Okay. Yeah, that's all from our side today, and I think we'll carry on with another session next weekend maybe. Thanks, Suman. Thanks, everyone. Happy weekend. Bye, guys.
Yeah. Thanks a lot, everyone. Goodbye.